Welcome to the HVAC ology experience, where we talk about all things HVAC industry, topics that are so hot, they are cool.
Episode number 8, here we go. Kelly Patterson, how are you today?
Ryan Hudson, it's been a day.
Why has it been a day?
Well, I'm here in Los Angeles, California. I've been here for several days and had some flight issues. And so I'm recording from the beauty and wondrous amazement of LAX.
So have you been to Oakland before as well?
I have been to Oakland, but it's been a really long time.
So now you know exactly what Anthony L. Roy, the great poet, also known as Sir Mix-a-Lot, said in his 1992 Baby Got Back when he referenced both an LA face and an Oakland booty.
He did. He did. I think I've seen both, maybe just today.
Oh, very good. Well, as you come back from Los Angeles, I head out for 2 weeks to South Africa.
I'm so excited for you.
Yes, and so the next time we get to record together will be a hot minute.
It will be
But
post safari. I assume you're going to go on a safari, right?
it'll be a brief safari. So I have a brother-in-law that owns, are you ready for this?
I am.
30,000 acres of land. So it'll be 30,000 acres of farmland in South Africa
My gosh.
that we'll be living on. And the reason why you have to have so much acreage is because apparently they do livestock and it takes more acreage per head of animal to be able to support them. So you got to have a lot of space in somewhere like that. But
Woo,
I'm
that's
excited.
exciting.
I'll be a farmer. I'll be living in caves. Yep, looking at the stars. I'll let you know everything when I get back.
I hope you bring pictures.
So Kelly is going to mute
Yes, I am.
because she has gotten a lot of background stuff going on, and I'm going to handle it from here, and then we're going to bring Kelly back here towards the end. Or Kelly, if you have a good question, come on. So we have Mr. Mike Kollmansberger, who we are interviewing today. He is with the Metro Group, a chemical company that provides chemical water treatment, glycol, and we'll kind of go into all of that. And Kelly, just for future reference, we really need to add kind of that between two firms, Mike, or the Galifianakis show that he does. We need to have the between two ferns where people's names are just absolutely slaughtered and misspelled at the bottom.
Absolutely.
So, Mike, you and I go way back. How you doing, brother?
Good. Really good. Glad to be here, Ryan. Appreciate it.
Good. Yeah, I'm so grateful to have you on board. You have been fantastic to work with over the years and just have enjoyed getting to know you better over the years as well. So one of the things we like to ask Mike is kind of a 5,000-foot view. Quickly take us, kind of how did you get from high school to chemical treatment?
So I'm from Dallas, Texas originally, and went to high school in Garland, left there, went to the University of North Texas, famous for Mean Joe Green, who was a phenomenal Pittsburgh Steelers football player. And I think it's Louis de l'Amour, I think is the guy's name, who was a Western romance novelist. I don't know. I've never read one of those books, but he also attended the University of North Texas. So we got a few A-listers there. So I graduated in the mid 90s, moved overseas to Eastern Europe, lived and worked over there with a college student ministry, and met who became my wife. She's from North Carolina. She was also over there. We came home, got married, went full time with that Christian organization, working with college students. Did that for almost 10 years and felt like it was time to make a change. So that led me to have my brother-in-law, who was the district manager for the Metro Group in chemical water treatment, offer me a job. And that's how it started. And I've been with the Metro Group the last a little over 18 years.
Okay, very good. And you and I met each other probably 15-ish years ago, something like that. Somewhere in that
Right.
ballpark.
So Seth Stanton was a friend of mine, and during my previous career, I worked at the University of Kentucky for 3 years. And so at that time, well, I should back up. When I met you, that was through Seth Stanton when you were both at Carrier.
Yep, that's right. That is right. Very cool. So let's kind of get into the meat and potatoes. What does chemical treatment actually do?
So we've got a few, as you can imagine, we got a few catchy phrases, and a couple of them are make it slick so it doesn't stick. Well, I tell you what, I'll leave it at that one. What essentially it does is, since water's the universal solvent, which means it'll tear anything up given enough time, and that water kind of seeks an equilibrium. In other words, it's not happy in its current state. It wants to bring matter and material into it to kind of stabilize itself. And that's a gross oversimplification. But because of those things, it needs a buffer to protect equipment. Equipment's obviously made out of metals, or at least most often is, and that metal also wants to revert to a lower energy phase. So because of those things, there's a process that we always have to try to arrest. And the only way to do that, or the most effective way to do that, is with chemistry. And so therefore you have corrosion inhibitors and polymers and other products that slow down that process almost to a complete halt, but not a full halt, but almost. And then of course you have to add things like biocides and other products to make sure this equipment works as efficiently as it can. So your company will provide a piece of equipment to an owner, and that owner wants to extend its life much longer than what you told them, because you told them 12 or 15 years, and he wants it to go twice that long. And we can sometimes help do that by minimizing the properties of water, the impact of the properties of water on that piece of equipment.
So how often have you gone and looked, and it's a system where they didn't put any chemical treatment in it? They just hit the button with the water they had in the loop, and they went on. What do you see that very often? And if so, kind of what are the results of just using standard city water?
Well, how often do I see that? I see it probably 4 or 5 times a year. And that's more than I would like to see it. But typically what happens is both scale, all three, scale or deposition, corrosion, and fouling. All three of those three that we're trying to prevent take place, and they happen simultaneously, and they prevent the equipment from running efficiently, and it tears up. So the objective of why that equipment was there in the first place quickly gets blunted and then becomes a big problem for the owner. If you wanted to, you could use city water, fairly effectively if you knew exactly how to maintain it at what proper ratios. The problem is that if you knew that much to maintain it at proper ratios, you'd also realize that it's much easier and more effective just to use chemistry. So that's what I found, is that people that use city water and just hope for the best are those people that either are not really aware of what damage could happen, or they don't know how to contact the right people to help them make it happen.
And then concerning a closed loop versus an open loop, so a closed loop is not open to atmosphere, so there's no air in the system, or has the ability to be affected by air outside to atmosphere, or an open loop, which is typically like a sump or a cooling tower or something like that. Do you have to treat those two things differently, a closed loop and an open loop?
Definitely you have to. And the definition that I give people is an open loop is one that its standard operation requires additional makeup water. So a steam boiler or a cooling tower, it's by nature will lose water. Even if nothing else, the steam boiler will lose it through blowdown, and the cooling tower will lose it out the top through evaporation and then bleed off. So it is an open system in that it constantly needs more water to come on in and replace what's been lost. A closed loop is one that literally should lose no water and should retain all of it unless there's a minor issue. Now, of the closed loops, there's two different kinds. There's like an HVAC true closed loop where there's no air influence or intrusion, and then there's process water. So you might have some incidental loss through evaporation from that open sump, but you shouldn't have a lot like an open loop. And the treating of those systems is quite different. The big difference is when you have an open system and you're losing water through heat rejection and evaporation, or if you're making steam, the impurities in that water that's coming into the system accumulate. And when they do, it builds up and up and up and up. And what happens is it reaches a saturation threshold and it can no longer stay in the water. And so it literally will fall out or precipitate, and it'll form a solid in the worst possible place, which is your heat transfer location. And people, obviously, it's seen immediately because, hey, I can't get heat. Hey, I can't get cooling. What's happening? Or my product's not sticking to the roll anymore. Or, you know all these, Ryan, ad infinitum. You've heard them. And that's when there's an issue. They open up a piece of equipment and it's just full of black, whatever, terribleness. And then you end up calling me. And then we talk about it and devise a plan. So on a closed loop, what you want is to add the chemical one time and hope that there's no water loss in that system and check it periodically. So those are going to be film forming inhibitors and other passivating products. Whereas with an open system, you're going to want to make sure that you've got, of course, things to kill microorganisms in a cooling system, but also corrosion inhibitors and a polymer to help keep the higher solids from sticking together and keep them moving. Steam boilers, fairly similar. You want to protect the system from corrosion. You use sodium sulfite, you'd use sodium hydroxide to raise the pH, but you also want to kind of keep the contaminants from sticking together and forming a solid. Hence what I said earlier, make it slick so it won't stick. We don't want this stuff to stick together. We want it to clump together, but not stick together so we can blow it down at the bottom of the boiler. And so we'll add different products to make that happen. So really, as a HVAC professional, when you see you've got a hydronic system and you can identify what it is, but you don't have the chemistry needed, you just reach out to your local professional and say, hey, tell me what I need, tell the customer here what they need, and provide these products for us that make sense at a good price.
And then something that I've ran into, I'm oftentimes in industrial settings, and I noticed that some of these places, they don't really think through decoupling the process from the cooling loop. And what happens is whatever process they got going on, the oils and all that, it kind of starts to sludge your unit. And then all of a sudden now your chiller that should have been, an air-cooled chiller lasting 15, 20 years, or a water-cooled machine that should have lasted 30 years, now is all of a sudden losing, it's dying within 5 years and catastrophic failure. And so, the importance of decoupling your chill water loop from your process loop is insanely important through the means of some kind of heat exchanger. Typically something that you can clean pretty easily as far as if you got kind of a filthy process side.
Agreed. I think if you cannot decouple, then find some method to protect those systems, especially like you talked about with an air-cooled chillers. A lot of those times they may have some type of brazed plate and heat exchanger installed, which is non-serviceable, or they may have passages that are too small and they're just not going to accept any fouling whatsoever. So add filtration or add a product that will keep that material from gumming up long enough so you can flush it out. I mean, there's a variety. There's no lack of solutions to problems, but you have to, I guess, like Ryan, like you said, you have to look it in the eye and recognize what it is. And a lot of times having a secondary loop is the best solution long term.
Mm-hmm. Yeah. Yeah. And not just that, but making sure that if you have a nasty system, make sure you get the right heat exchanger that you can easily, like I said, clean. So going back to it, so we've kind of talked about as far as chemically treating it to kind of make sure the metal stays where the metal is going to be and the water stays where the water is going to be. Now, what about glycol as far as in like a low temp situation? Kind of walk me through kind of what glycol does, and not just what it does, but percentages that you need to be mindful of, because that's something that we're always trying to talk through, you and I, whenever we're talking. So just educate the listener a little bit on glycol.
Okay. The first thing I would say is there's a really common misperception about glycol. People will say when they need to protect the internals of their system, they'll say, hey, I need you to give me some glycol. And that's actually not what they're asking for. They want a corrosion inhibitor, and they just assume that glycol is the answer. And so I'll push back and say, no, that's not what you want, nor is that what you need. Let's talk about that. That's a separate discussion. Now, when people actually do need glycol, what they really need is either freeze point or boiling point suppression. They want to push that number away. So obviously the freezing point of water is 32 degrees, but let's say, like I just had a customer in the upstate say, hey, we're going to run this chiller down to 33 degrees. I've got to have glycol. And I'm like, you need to have glycol. Or if you've got a comfort cooling chilled water loop, and you've got air handlers on the roof, and there's no way to protect those coils except with glycol. So a number of things that you guys do in your industry, Ryan, are, you'll cycle the pumps, you'll have, control logic to cycle the pumps, or you'll have heat tracing, or you'll have heat strips, or things like that. Those are all good. But I get the customer sometimes saying, hey, well, what about when the power goes out? What do I do then? Like, well, glycol does not need any power. It will always protect your system. So some fundamentals about glycol is it's not just one thing. There's a variety of types. So for instance, there's ethylene and propylene. Now, the common idea about that is ethylene is more friendly in terms of its ability to absorb and reject heat. Therefore, it doesn't have as big as a heat coefficient loss that propylene does. So people will opt for ethylene. Hey, I like that better. It's going to save me on pump sizing. It's going to save me on energy consumption. The downside to ethylene is that it's considered toxic. The chemical chain of it is longer, and so it takes longer to break down in water, aqueous or water situations. So it's considered toxic to humans. Propylene is not considered toxic, but the problem is that it doesn't have as good transference of heat. So you're going to have to upsize, or I should say, add extra tonnage in when you rate your chiller. You're going to have to bump up the size on your pump impellers and potentially your pump motors. And just know that in advance, it's going to cost you a little bit more. Now, it's not toxic, so there's a benefit to that. And it's a little bit easier seemingly to get and have people add it just slightly. So there's a variety of there. There's something else that's really, really, really important from a water treatment perspective, and that is that glycol is ultimately some type of an ether. And so it's a consumable by microorganisms. They will absolutely eat it as a food source. So what we recommend, without doubt, to every single person, and you've heard me say this many times, you have to have a minimum of 20%. If you don't have a minimum of 20% glycol in any hydronic loop, you are asking for trouble, and eventually you're going to get it. And the reason is at 20%, that for whatever reason, it ties up enough oxygen inside that system that the microbes can't replicate, or they don't do it effectively such that they can grow and start using the glycol as a food source. It keeps them inhibited, and so you're protected in that way. I cannot tell you over the last 18 years how many glycol systems I've come across that I open the valve to get a sample, and it looks like chocolate milk or Pepsi, or like somebody's bleeding out. It is so bad, it's unbelievable. In fact, there was a guy in Union, South Carolina, that had a plant, and he had me come in and take a look at it. And his guys were dumping in extra glycol every single month. And I took a lab analysis, and this is the record: 6,621 ppm of iron in their system. I've never seen anything higher than that. And he looked at me and he said, I'm just uninstalling my piping from inside out, aren't I? I said, that's exactly what you're doing. You are literally destroying your system. I said, you got to stop doing that immediately. And so we were able to help him and get that system cleaned up. And you know what? I think, Ryan, you're the one that sent me to that place.
Yeah,
I'm going to have to look and you are?
Yeah, I am.
Yeah.
Yeah, we
Yeah,
won't
it
say
was,
the
I
name.
don't want to say the
Don't
name on the air,
yeah,
but
yeah.
now that I think about it, that was you.
It
That's
was
right. It
me.
was a long time ago.
Yeah.
Yeah. So we see lots of problems. But again, with the glycolic system, if you've got a trained professional that's keeping a periodic eye on it, there's no issues. They really are easy to maintain. But when you don't watch out for them and you go to sleep on them, they're going to come back to haunt you. Let's see, I think I covered the primary components of glycol. Was there any follow-up question you had to that?
Yeah, well, kind of a comment to add to what you said. So I've whenever you're dealing with outside air coming into a building and you're in a situation in the middle of winter and you could have it to where you have air from the outside pulling in across coils, you need to make sure you have glycol in there, especially in those cold winter months, because you could bust a coil thinking that you're completely fine, but that outside air hitting that coil could cause damage to that coil that you're going to have to rip open the unit and replace the coil. So but definitely make sure in outside air situations. Another thing I was going to say, as far as ethylene and propylene, we had to make sure we had that completely right one time because a local zoo had me come in. They could not get the penguins cold enough, and each penguin, I think at that time, cost about $20,000 a pop. So we had to make sure that they were staying completely cool. One from just wanting to take care of nature, take care of the penguins, but also for the sake of the investment that the zoo had. And so we had to be very careful to make sure we had the proper glycol in there so that they would, if anything were to happen to them, they wouldn't get into it and die from that. So good information. So you also hit on something as well. Whenever you're adding glycol, make sure that you're make sure that whoever the manufacturer is of your piece of equipment, that they run the selection with glycol in it. Every single OEM, every single manufacturer has the ability to run their machines with glycol, because what happens is you have nominal tonnage and you have actual tonnage. Nominal tonnage is they say that this is a 200-ton chiller, right? Air cooled or water cooled or whatever. Actual tonnage is based off of whatever conditions you are presenting to the piece of equipment. And so no glycol, that 200-ton machine might really be a 180. With glycol, depending on your percentage, you could be a 150, you could be a 120, and all of a sudden your comfort cooling needs are not being met, or your process needs are not being met. So be very careful whenever you're adding glycol to make sure whoever manufacturer it is, and it can be an existing machine, they can still go back and check it. Make sure that you know that when you add that glycol to it, that it can handle it, and you can actually get the cooling needs that you have out of it. So another question, is it possible to have too much chemical in a loop?
Absolutely. Well, let me start with glycol and then work my way backwards. Really, at 50% glycol, adding any more, it would be pointless. I think the freeze point when you've got 50% is -31. So at some point, you just don't need any addition past that. And yet
Right.
the consequences, because glycol is much more viscous than water, the consequences still pile up. The ability to reject heat still pile up. And so you're going to derate your system the more you add, with getting no benefit from it.
Right. And
So that
also the amount of work that your pump has to do because of the viscous nature of the water. So your pump's going to have to work harder, which means you're going to need to probably increase the horsepower of that.
absolutely. Now with cooling towers and closed loops, let's start with closed loops. Can you add too much corrosion inhibitor? Yes, you can, because at some point it can elevate the pH too much, or it can cause so for example, one of our most common closed loop inhibitors is sodium nitrite. Well, nitrite can be considered an oxidizer. So if there's too much present, what it can do is damage pump seals. Like I've got a customer in Greenville that literally changed to me because the vendor they had added too much chemical in their closed loop, and it was coming out in a variety of the gaskets. It was literally squeezing out, or whatever the right term is, of the gaskets, and leaking all over the place. And it was due to excess chemical addition. And so that's a real potential problem. Again, testing and monitoring periodically will catch that, and you can adjust it. Not a big deal. Cooling towers, what will happen is if you add too much of the biocide or corrosion inhibitor, they have a direct impact on the not turbulence, but the ability of the water to foam. So if you've got a very turbulent cooling tower water delivery system inside the cooling tower, and you've got excess chemical, you're probably going to have a lot of foaming take place. And that could be a real problem because it could then fool the water level sensor, or it could get airborne and tossed and land on nearby cars. Of course, I know this because it's happened. We've had to deal with it. And steam boilers is probably the most sensitive to excess chemical feed. What happens is if you have too many solids inside your steam boiler, the steam, the water, and the listeners can't hear this, but I've got my hands here. This is the water level inside a steam boiler with the steam water interface here. If the solid levels are too high, when the steam tries to leave, it's wet. And so it doesn't want to break free and exit out through the dampener or through the anti-siphon valve. It wants to pull water with it. And so now instead of dry steam that's very effective at doing its job, you've got wet steam, and wet steam causes some pretty significant issues. And the biggest ones usually are in hospitals or wherever a steam's coming in contact with an end product. Really can be a real issue. And it can cause the boiler to surge and prime, and the water will start bouncing inside the steam boiler and then even potentially fool the low level water cutoff. So next thing you know, the steam boiler trips off and nobody understands what happened. And the process is down, the plant goes down, they got to send people home. It can really be an issue. So that's why we find a lot of value in monitoring these properly. Again, it doesn't require, a degree or any sort of super amazing insight, but some fundamental knowledge of chemistry and the chemicals that you're applying, and just a little bit of care, paying attention to what you're doing.
Very good. So what about potable water hygiene? Tell us a little bit about that.
In the 70s, in the Philadelphia American Legion Conference, a lot of people got sick from a cooling tower, and a lot of people actually died. And that was the genesis of understanding Legionella pneumophila, which is a pathogen. It's a bacteria that's always seemingly found in different bodies of water, whether it's groundwater or lakes or streams or cooling towers or potable water systems. And over the years, that's always been on our radar as chemical treatment specialists. We're always working around or in cooling towers. We're aware of this bacteria. We know how it works. We know you have to breathe it in. It loves the hospitable environment of human lungs. And so we just make sure that we are taking care of biocide applications. We're taking care of our people, our customers, our employees, et cetera. Well, as we've had more outbreaks starting in the late 90s and going through the 2000s, and especially the one in New York in 2015, it's gotten more on the radar that it's also present in potable water systems in levels that we didn't know about. And so since 2015 in the United States, they have been watching it. It's become law, as a matter of fact, in New York, that you have to test potable water systems, especially domestic hot water recirculating systems. That's been a real issue. So it's only law there, but things have been changing, and there have been more outbreaks over the years, whether it's a hotel or it's a manufacturing plant or inside long-term care facilities. And with the release of ASHRAE 188 about 10 years ago or so, that really put a large banner on awareness in terms of Legionnaire's disease and how water delivery systems are the key component to that. And so that's caused federal agencies to change their approach to it and start monitoring it. It's changed Department of Defense, the GSA. They've all kind of changed how they handle it. And it started first with Center for Medicare and Medicaid Services. And they started requiring water management plans and testing for long-term care facilities, critical care facilities, and hospitals. And since then, it's just grown further and further. And so ultimately what we're trying to do in the water hygiene space is to protect the most vulnerable. So people like us that listen to this podcast, engineers, people in the HVAC industry, we're probably been exposed to Legionella many, many times. And we probably have a pretty robust immune system, but there are those who do not, and they are still exposed to potable water through aeration or showers or whatever that could be contaminated with Legionella. And so it's on the rise in terms of awareness and trying to find ways to intervene safely and feasibly.
Mm-mm. Very good. So tell me about how the government is getting more involved with kind of your industry.
Well, regulation is always happening, of course, and is very ever present with any type of chemical. So we have to go through all the proper processes to register chemistry state by state to make sure it's approved by the EPA and is fully documented. So that's been there for probably 60 years. I'm not exactly sure, but roughly. And so that's a known entity that hasn't changed too much. But what has changed recently is government requiring certain procedures. So maybe it's registering your cooling towers in the case like in New York City, or maybe it's cleaning and monitoring by an industrial hygienist or a certified water technologist. Maybe it's a variety of plans that have to be done in order to you have to have these chemicals in your cooling towers or you're going to be fined. There's a lot of that's taken place in the New York area. But in terms of the domestic water side, which is what I was referring to, there's been a number of cases of Legionnaire's disease by federal employees over the last year or two, such that it prompted the GSA, Government Services Authority, to make a complete sweep and implement required testing of every single one of their buildings and every single one of their leased spaces in the United States. And that's about 6,200 facilities. And they started this last October, and they started phasing it into all these property managers and building owners starting in February in a phased rollout. So our company has been very involved with this and maintains all the certifications and lab facilities in order to do this testing. So it has been a huge thing on our radar the last 2 months. And I'm getting calls every day from people in different states. Hey, I need you to help me here, help me there, whether they're in Missouri or Maine or New Hampshire or Columbia, South Carolina, we're getting these calls and we're going out and performing these tests. So I think what's happening, Brian, is to go back and say the government's becoming more aware of risk that they see from their water delivery systems. And they're trying to find a way to protect their employees and probably mitigate their risk from what could happen. And just like I've reiterated in this podcast, most of all water problems are able to be resolved or kept in check with a water professional that understands what's happening, how to test, how to qualify it, how to quantify it, and how to remediate it if there's an issue. And whether it's a harmful pathogen in a water system, or whether it's corrosion in a cooling tower, or a busted coil, or a steam boiler that's gone awry, these professionals, like my company, like myself, and others in the industry, we understand how to implement the tools in our tool bag to give the best outcomes.
That is a very underrated gift that you have by being born in a first world country, is the opportunity to be next to clean water, and something that's very important that we as a nation take seriously to keep our water clean, and appreciate everything that y'all are doing in that space. So tell us about turning a customer that maybe was a critic and of what you offered, whether it be chemical treatment or glycol, into a believer.
I've thought about this a little bit, and oftentimes the people in the areas of responsibility that I interact with they typically know they have to have chemical treatment. They've usually taken a couple lumps and they know they have to have it, but they probably also had a bad experience. And so they're a little gun shy. So I wouldn't say I have a customer who was an unbeliever per se, but they were burnt. They've been burned and they were leery. And so I've got a customer I've had him for almost the last 18 years up in Greenville, South Carolina. And he had he has got a long-term care facility, and he had a cooling tower, and it was poorly maintained, very poorly maintained, and corroded out and ended its life way too soon. So he found out about us, contacted us, and I came in and met with him. And we proposed solutions not only to his closed loop by filtration, but also a completely different chemical feed control setup for his cooling tower. And he was concerned. He trusted us based on a recommendation, but he was concerned that he was going to have the same problem he had before. Mm-hmm. And so years have gone by, and he's still my customer. And within a year, he said, "Mike, I just cannot thank you enough for all that you've done to get us on the right track. I feel like I can completely trust now everything that you say you're going to do. I'm pleased that I don't have to think about it anymore." And subsequently, he had to start testing for Legionella at his long-term care facility, and our agreement with him quadrupled. So in terms of value, and he's so happy with what he does, even all these years later. I just talked to him 2 weeks ago, and it's been 17 years. He's like, "Mike, I still remember what you came in and did for us on the cooling tower system, and I'm so grateful that you did, that I met you guys, and you're still doing everything you said you'd do." And Ryan, I know you got customers that say the same thing, and it's mm-hmm. just great to know, I'm not transforming anyone's life with the work that I'm doing here, but at the same time, I'm making their life easier and better, and offering their stakeholders the best possible return on investment so they can do and bless other people. So I know in that sense, I am impacting my customers, and you get a really good feeling from it.
That's very cool. Mike, I'm grateful for you and grateful for what you're doing out there in the industry. And thank you for educating both Kelly, myself, and our listeners on things I didn't know about with chemical treatment. And Kelly, did you learn something new today?
So I learned a whole lot today, not only about chemical treatment, but also about closed loop and open loop systems. Those are a little bit more clear to me now. And another thing that I've learned is, Ryan Hudson, you have a really great circle of connections, really great people. It's just really fun to get to know people that you know. Mike, you seem like a great guy.
Thank you.
He is a great guy. I've known him for a long time.
I like it.
Well, good stuff. Kelly, what should people do if they enjoyed this podcast today?
They should definitely like and subscribe or make a comment. You can make any kind of comment. We'd be happy to hear your positive reviews. That would be fantastic.
And if you ain't got nothing nice to say, don't say nothing at all.
That's right. Do what your mama said.
All right. Well, thanks everyone out there. And I hope you have a wonderful, wonderful day. Bye.
Rocket past Saturn, things don't seem to matter much to me anymore. Got lost inside a daydream, get sick of all schemes they play on their machines. I lost so many words as I got older. You would have thought I would have stored them, and I'm under love folder. Accidentally wrote these words down. Thought all the best of me faded in an endless sea, but you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside, but you always bring me back at your blue eyes. more to me anyway. Got lost in reality, no answers to cancer, we never got to talk. Lost so many friends as I got older, wish I had the strength to hold you a little bit longer. Always meant to write these words down, thought all the best of you, faded in an endless sea. But you always bring me back into blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me. Get your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside? But you always bring me back. Get your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the songs inside of me. You were always inside of me.